This video will be about rational exponents. So we're going to start off with reviewing our exponent rules. We're going to just go over a few of them. So we have our first rule, a to the m times a to the n equals a to the m plus n. Okay, so an example of that would be 3 squared times 3 to the 5th equals 3 to the 2 plus 5, or 3 to the 7th. Okay, now you could check that in the calculator, but we're just going to use that property now and call that good. Another property of exponents is raising a power to a power. So we have a to raise to the m raised to the n equals a to the m times n. Okay, so let's say, for example, we have 5 to the second power raised to the third power, which will equal 5 to the 2 times 3, so that is 5 to the 6th. Okay, now we'll go ahead and look at another property. We have a to the m divided by a to the n equals a to the m minus n. So we'll go ahead and pick 7 raised to the 5th over 7 raised to the 3rd, which equals 7 to the 5 minus 3, which is 7 squared. Okay, so those are some basic exponent properties that we need to make sure that we are familiar with for our EOC, because they may come up. Now let's go ahead and move on to our rational exponents. Okay, so rational exponents, they're quite simple. They look a bit complex because we have fractions and radicals in them, but they're fairly straightforward. Okay, so if we're going from radical form, okay, so we have radical form, we're going to, here we'll put some notation in here, x to the m, the nth root of x to the m equals x to the m divided by n. Okay, and likewise, x to the m divided by n goes to the nth root of x to the m. Okay, now we'll do a few examples to remind ourselves of what this looks like. Okay, now as we go through these examples, you will be doing some as well. So let's go ahead and start with 3x. It's in parentheses. We have a radical there. There's 3. That 3x, we'll say that 3x is squared. Okay, now we're making an equivalent form. So our base is going to stay the same. Let's keep it in parentheses. Now this exponent is going to stay in our numerator, divide by our index here. So 3x to the 2/3. Those are equivalent. Let's see. Let's try the square root of y to the 5th. Okay. Now we don't have an index here. Now the thing with square root is we cannot assume that it's 1. We have to assume that it is 2. All right, so let's go ahead and look at a couple for going from exponential form into radical form. So let's pick 2x to the 7 over 4. So then that denominator is our index, the 4th root of 2x to the 7th. Notice how since the base is in parentheses here, the base is still in parentheses here. Okay, have to make sure that we're in parentheses there. Let's do another one. Let's try z to the 1/2. Okay, now since 2 is in our denominator, just like we saw up here, the 2 is in the denominator, we just had a square root. So we have the square root of z. And since our exponent will be 1, we don't need to have it there. Okay, so you'll do a couple on your own here. Now, I want us to look at a problem that we've seen on some of our exams. I think we've seen a problem similar to this twice, is where I'm wanting you to simplify this so we have 2 radicals. Okay, all this is distribution, but the first thing I'm going to do, rewrite into exponents. Okay, so we have 4 times x to the 1 over 3 times 5, or with in the parentheses, 5 times x to the 1/2 plus 6 times x to the 3 over 4. Okay, so we have the same base. So we have 4 times 5 is 20. X, this is our exponent property, is 1 over 3 plus 1 over 2. Okay, now we're going to distribute again to the other term. So plus 24 x to the 1/3 plus 3 over 4. Okay, so our second step is to distribute. And we did just that. Okay, so our third step is to simplify the exponents. Okay, so that's going to give us 20x to the 5 over 6 plus 24x to the, let's see, 13 over 12. And then we have to lastly, there we go. Lastly, rewrite into radicals. Okay, so we have 20, and since the 6 is the denominator, the 6th root of x to the 5th, plus 24, and since 12 is the denominator, the 12th root of x to the 13th.